Good day, geographers, and welcome to another series in our geography lesson. I am your host, Donovan Rattray. Today's lesson is the motions of the Earth, and there are two motions that the Earth actually does. They are rotation and revolution. So let us first look at the very first one you see popping up underneath the main heading, rotation. Okay, so what is rotation? As implied by the introduction of the word itself, as you can see, it was turning. Well, rotation is actually the west to east turn motion of the Earth as it turns on its axis. Basically, students, what that is saying is that the Earth is actually turning. Not necessarily spinning, which implies that it's moving very, very fast, but it's a very slow movement. So we just simply say it is turning, and it is turning on an invisible but imaginary line that we call the axis. Now this passes right through the center of the Earth. Now when the Earth is turning on its axis from west to east, it takes approximately 24 hours to complete this motion of a 360-degree turn. Now this will create the effects of night and day. Yes. So as the Earth is turning, one side of the Earth is actually facing the sun and the other side is turned away from the sun. Now the side that is actually facing the sun will receive light and will therefore experience day or daylight conditions, while the side that is turned away from the sun will experience darkness, otherwise called night. So here we have a diagram of the Earth turning on its axis. As you can see, that white imaginary line passing through the center of the Earth is its axis. We said it's imaginary because we cannot see it, but we can only imagine that it's actually there. Now the funny thing about the axis is not totally straight or properly inverted. It's actually tilted. Now this tilt will play a very important role when we move on further in the lesson. But for now, let us work with the fact that we have an imaginary line passing through the center of the Earth known as the axis that actually tilts to one side. Alright, and this is the imaginary line around which our planet Earth is actually turning or rotating. Now the arrow tells you that it's actually rotating from a westerly position, so it's turning from west and moving towards the east. And that is what we call rotation. Now as you can see, the sun, which is right here, is actually facing one side of the Earth. Now that side of the Earth that is facing the sun will receive daylight conditions. So it's experiencing day. While at the same time, the side that is turned away from the sun is darkened and therefore will experience nighttime conditions. So this turning or this motion of the Earth actually allows both sides of the planet to experience opposite conditions of light at the same time. Hence, you have night and day at the same time being experienced by both sides of the planet as a result of this turning motion. And yes, students, remember, it takes 24 hours to complete this rotation.
Rotation is the movement of the Earth on its own axis. Rotate means to turn, so the Earth turns around a slightly inclined imaginary line that joins the two poles called the axis. Do you know how long it takes to make a complete turn? It takes 24 hours to make one rotation. Think about it for a second. One day, day and night together, lasts 24 hours too. So the movement of rotation causes day and night. Interesting, right?
All right, class. So you see how easy the topic of rotation was? Now we're going to be moving on to the next movement of the Earth's, and that is revolution. Now this is going to be considerably much longer than rotation, but bear with me as I try to make you fully understand what revolution is all about. But let's look at the very first part of this motion of the Earth and what it's really all about. Okay, so revolution is basically the journey of the Earth around the Sun. Sometimes we call it an orbit. Either way, it's actually the journey or the path traveled around the Sun. Now, this journey takes approximately 365.25 days. In other words, that will be 1 year. Now, keep in mind that other planets have a much longer or even shorter journey around the Sun, so therefore their year varies in comparison to Earth. Some have 1 year being way over 365.25 days long, and some have as short as 88 days within their year because they take a much shorter time to go around the Sun. But anyway, let's focus on Earth. So as I said a while ago, revolution is the journey or the path taken by the Earth around the Sun. And this takes approximately 365.25 days, which is basically 1 year Earth time. Okay? Now, another thing I want to make clear is that that quarter is very important because every 4 years, that quarter of a day adds up to 1 whole day. Now, at the end of every 4 years, the quarter adding up to 1 day gives us an extra day on the calendar. And this is what we call a leap year. Now, this is why the month of February ends up having 29 days every 4 years. It is what we call a leap year. Usually February has only 28 days, but every leap year February gets an extra day and we call it a leap year. So we'll have February 29. You're probably wondering, okay, what if I was born on February 29? How would that work out? Well, you just have to celebrate your birthday on the 28th of February until the next 4 years. You can celebrate on the 29th. Bummer, isn't it? But anyway, that is what the quarter is all about. So even though we have 365.25 days, every 4 years the quarter adds up to a complete day and we get an extra day. Therefore, we call it a leap year. And that is the reason why every leap year, February, instead of having 28 days, gets 29 days. Now, remember I told you about the tilting of the Earth's axis? Okay, let us see what we're talking about here, because I tell you that tilting is very important. Now it goes on to say that the movement along with the tilting, yes, because of as the Earth goes around the Sun, it actually tilts or leans or inclines to one particular side. Now this tilting of the Earth while it is traveling around the Sun has an effect on the amount of sunlight both hemispheres, north and southern hemisphere of the earth, actually receive. Now, because of this variation in the amount of light that both hemispheres receive, we experience what are called the 4 seasons. Okay, so because of the earth's traveling or journey around the sun, along with its axis tilting, it affects the amount of sunlight both north and southern hemispheres receive, and therefore this is what we call the seasons. All right, everyone, so now here we have a chart showing the 4 seasons. So we have spring, summer, autumn, and winter. Now, each season lasts on average 3 months. Some have longer days than others. As you can see according to the chart, spring has 93 days, summer 94, whoopee, longer summer holiday, right? Autumn 90, and of course winter, the shortest, thank God, 89 days. So in the northern hemisphere, where we are located, all right, and where some people who are probably watching this are not located, some people who would be watching this video are probably located in the southern hemisphere, right? But here we are, we're in the northern hemisphere, and spring in the northern hemisphere lasts from March 21 to June 20. In the southern hemisphere, spring happens on September 23rd and it goes up to December 21st. Summer in the northern hemisphere, as you can see, lasts 94 days. That's the longest one, and that's on average, right? Now in the northern hemisphere, it starts on June 20 and it ends September 22. Okay, September 22. Something's not right, right? So you're saying that we go to school during summer? Yes, unfortunately. All right. Sorry to throw that monkey wrench in all of that, but yes, we do not celebrate all of summer for the 94 days. I'm sorry. All right. Now in the southern hemisphere, summer starts on December 22nd and it goes up to March 20. Now let's kind of pause here a little. I don't know how many of you can remember 2016 when we had the Summer Olympics in Rio de Janeiro, Brazil, but it was held in Brazil when we are experiencing summer. The interesting thing about Brazil is that Brazil is south of the equator. Now, being in the southern hemisphere means that while we in the northern hemisphere are experiencing summer, even though it was called the Summer Olympics, it was in truth, well, winter in Brazil, and it really threw off a lot of our athletes in Rio de Janeiro, but nonetheless we still came home with a bag of gold medals, right? But so that's how weird the extremes can be. So while we're actually experiencing summer in the northern hemisphere, at the same time in the southern hemisphere, there is winter going on. As you can see in the chart, winter actually starts on June 21st while we are experiencing summer, and that's kind of weird, right? But let's take our little time, go through the chart. So as I was saying a while ago, summer begins on June 20 to September 22. In the southern hemisphere, it is on December 22nd to March 20. Autumn in the northern hemisphere is September 23 to December 21. And in the southern hemisphere, it's March 21 to June 20. And winter in the northern hemisphere is on December 22nd to March 20. and in the southern hemisphere it is June 21st to September 22. All right, so while it is spring in the northern hemisphere, it is actually autumn in the southern hemisphere. Let me show you. So here we have spring in the northern hemisphere on March 21st to June 20, and while we're experiencing spring in the northern hemisphere, like, all right, around the same time in the southern hemisphere they're experiencing autumn. When we are experiencing summer in the northern hemisphere, the southern hemisphere is experiencing winter, and that is the reason why when they had the Rio de Janeiro games back in Brazil, Rio de Janeiro, Brazil, back in 2016, it was bitterly cold in Brazil. All right, so while we're experiencing autumn on September 23rd to December 21, the southern hemisphere is experiencing spring. And as you can see, while we are experiencing winter in the northern hemisphere, right, on December 22nd, the southern hemisphere is experiencing summer. All right, so as you can see, so let me go again. So while we're getting spring in March in the northern hemisphere, the southern hemisphere is getting autumn. When we're getting summer in the northern hemisphere, the southern hemisphere is actually experiencing winter. While we're experiencing autumn in the northern hemisphere, the southern hemisphere is experiencing spring. And while we're experiencing winter in the northern hemisphere, the southern hemisphere is also experiencing summer. All right, so that is what the table is actually telling us. I hope it's clear. If not, you can always rewind. All right, so having looked at that chart, we are now going to be looking at our seasons individually. So first of all, we're going to be looking at the summer solstice and the winter solstice. Now, the word solstice comes from the original word for the word sun. Solstice refers to sun or sunlight, because the original word for sun is sol. Now, if you know your Spanish well, the word for sun is sol, and that's how we come by the word solstice. All right, it's also in Latin. So now, what is the big deal about summer solstice and winter solstice? Remember, we're talking about the tilting of the earth axis. Well, I'm going to infuse it in this, so please pay keen attention while I try my best to let you understand. Now, during September to June in the northern hemisphere, the earth is going to tilt facing the sun. All right, so the earth's axis is going to tilt facing the sun, which means therefore the earth northern hemisphere is going to receive longer hours of sunlight, and as it receives longer hours of sunlight, it gets very hot. All right, so it's going to experience what is called the summer solstice, while at the same time in the southern hemisphere the earth is tilted away from the sun, so they're going to get less sunlight. And as they get less sunlight, they're going to experience much cooler conditions, and there's what we call the winter solstice. Now, during this time in the southern hemisphere, the earth is going to receive longer hours of darkness or night conditions and shorter hours of daylight, while we in another hemisphere is going to receive longer hours of daylight and shorter hours of night, because we're getting more sunlight. All right, and that is the reason why during the summer months, as soon even when it is 6:30 in the evening, we're still getting good amount of sunlight. All right. But in December, if you notice, in the winter months between December and March, as soon as it reaches 5:30 or even 6 o'clock, the time gets dark, because during this time of the year we receive less sunlight, because our section of the earth, which is the northern hemisphere, will be tilted away from the sun. All right. Oh, before I go any further, let me make it clear. All right. By the way, let me ask this question. Which line of latitude divides the earth into equal hemispheres, into northern and southern hemispheres? It is valued 0 degrees. Come on, who remembers that? Come on, primary school stuff. All right, I'm sure you know, and I'm sure you just answered it a while ago. Yes, it is the equator. Now, the equator is that line of latitude that divides the earth into north and southern hemisphere, into equal hemispheres. So during June to September, the northern hemisphere of the earth is tilted towards the sun, and it's received more sunlight. So as it receives more sunlight, it gets longer hours of daylight and shorter hours of darkness, and therefore it even experiences much hotter conditions. So at this time of the year, between June to September, the northern hemisphere is experiencing what is called the summer solstice. At the same time, the southern hemisphere is tilted away from the sun, receiving less sunlight. You're having cooler conditions down there, right? And at the same time, it is also receiving longer hours of darkness, shorter hours of night, and shorter hours of daylight. So it gets shorter hours of daylight, longer hours of darkness. So it is experiencing what is called the winter solstice. So you see how remarkable this is. At the same time, while we are experiencing summer solstice, the southern hemisphere is experiencing winter solstice. And while the winter solstice is going on in the southern hemisphere, the northern hemisphere is experiencing the summer solstice. All right, and in around December, the opposite happens, where the northern hemisphere is tilted away from the sun and the southern hemisphere is tilted towards the sun, and therefore you have summer in the southern hemisphere and winter in the northern hemisphere. Quite a remarkable trip, isn't it, everyone? Right. So, as I was saying, all right, a while ago, between December to March, the southern hemisphere is tilted towards the sun, therefore receiving more sunlight. The southern hemisphere goes through the summer solstice, experiencing longer days and shorter nights. Meanwhile, places in the northern hemisphere are going through the winter solstice, where they witness shorter days and longer nights. So basically, all this is giving you is the opposite of what happens, all right, during the summer solstice. Geographers. Now, did you know that the longest day in the northern hemisphere is the 21st of June? Yes, the longest day of the year in the northern hemisphere is 21st of June. And this is because on this very same day, the northern hemisphere receives the longest hours of sunlight than any other time of the year. As a matter of fact, all places that are north of the Arctic Circle receive 24 hours of sunlight. And that is because at this time of the year, the Earth is tilted a little bit more closer to the sun than usual. Therefore, it will receive longer hours of sunlight. And that is why on this very day, for example, even here in Jamaica, we realize that even at 6:30 in the evening, we still have good amount of sunlight. However, all places that are north of the Arctic Circle will receive 24 hours of complete sunlight, no darkness on this very day. As a matter of fact, there are places in this location that actually are defined by such event. For example, in the country known as Norway, there is a place known as Lapland, and Lapland, just like the rest of Norway at this time of the year, is often regarded as the land of the midnight sun, simply because even at midnight it is still daylight. The sun doesn't set at this time of the year. Now, as a result of the Earth's unusual tilt, in the southern hemisphere, the Earth is tilted even further away from the sun than usual. And that means that all places south of the Antarctic Circle will receive 24 hours of darkness. As a matter of fact, in the southern hemisphere, June 21st is regarded as the shortest day of the year. However, in the northern hemisphere, June 21st is the longest day of the year. Now, on December 22nd, in the northern hemisphere, December 22nd is regarded as the shortest day of the year. And that is because the Earth is going to be tilted away from the sun and going to be tilted even more further away than usual. This means that all places north of the Arctic Circle during December 22nd will receive 24 hours of complete darkness. Ooh, scary. While at the same time, in the southern hemisphere, the Earth is tilted even further or closer towards the sun than usual. This means all places south of the Antarctic Circle will receive 24 hours of sunlight. So you see, once again, the whole tilting of the Earth's axis comes into play. So because the Earth has tilted further or closer to the sun than usual on the 21st of June, all places north of the Arctic Circle receive 24 hours of sunlight. And at the same time, all places that are south of the Antarctic Circle will receive 24 hours of darkness. That is because the Earth is tilted further away from the sun than usual in the southern hemisphere. All right, but on December 22nd, the longest day of the year in the southern hemisphere, the Earth is tilted closer to the sun than usual, and therefore all places south of the Antarctic Circle receive 24 hours of sunlight, while in another hemisphere, because it is tilted away from the sun than usual, all places north of the Arctic Circle will receive 24 hours of darkness. And on December 22nd, this is the shortest day in the northern hemisphere, while it is the longest day in the southern hemisphere. So you see, the opposite tends to happen at both sides of the hemisphere, simply because of the tilting of the Earth from the sun or towards the sun at particular times of the year. Okay, so as you can see now, everyone, this is the diagram showing the revolution of the Earth as it moves around the sun. And during the summer period, you notice the Earth is tilted towards the sun. All right, as you can see, that red line going through the center of the Earth is its axis. So it shows the Earth tilting towards the sun, and therefore all places north of the equator will receive far more sunlight. And that means on June 21st, all places north of the Arctic Circle, which is right up here, all right, will receive 24 hours of total sunlight, while all places south of the Antarctic Circle, because it is tilted away from the sun and even further away from the sun as usual, will receive 24 hours of darkness. And that's all places south of the Antarctic Circle.
Summer solstice. On the 21st or 22nd of June, the overhead sun is over the Tropic of Cancer. It receives the largest amount of solar radiation. At this time, the northern hemisphere is in the summer solstice, while the southern hemisphere is in the winter solstice. The angle of the sun decreases towards the poles. On this day, the length of daytime of the northern hemisphere is the longest in the year, while that of the southern hemisphere is the shortest in the year. Besides, there are 24 hours of daylight at the Arctic Circle and 24 hours of darkness at the Antarctic Circle. Winter solstice. On the 21st and 22nd of December, the overhead sun is over the Tropic of Capricorn. It receives the largest amount of solar radiation. On this day, the northern hemisphere is in the winter solstice, while the southern hemisphere is in the summer solstice. The angle of the sun decreases towards the poles. On this day, the length of daytime in the northern hemisphere is the shortest in the year, while that of the southern hemisphere is the longest in the year. There are 24 hours of darkness at the Arctic Circle and 24 hours of daylight at the Antarctic Circle.
Now, geographers, we're going to be looking at the spring equinox and the autumn equinox. Now, if you pronounce the word or listen to the word equinox, you will realize that the first half of the word equi sounds pretty familiar, right? Well, it does sound like the word equal. Well, that's what it actually means, equal. Now, equi, referring to equal amounts of sunlight and also equal amounts of darkness, because at this time of the year, or at these two times of the year, the Earth's tilt allows for both hemispheres to actually experience 12 hours of darkness as well as 12 hours of light. Yes, both the northern and southern hemisphere actually experience the same amount of sunlight as well as the same amount of darkness. Neither is tilted away or towards the sun at this point of the year. And that is why we call them the equinoxes. So both spring and autumn are what we refer to as equinoxes, because at these two times of the year, both the northern and southern hemispheres of the Earth receives 12 hours of daylight as well as 12 hours of darkness. In the northern hemisphere, the spring equinox, as you have already seen from the table, actually appears during the months of March and June. Autumn actually appears between the months of September and December. And during the time we're experiencing the spring equinox in the northern hemisphere, the southern hemisphere is experiencing autumn. And while the northern hemisphere is experiencing autumn between September and December, the southern hemisphere is also experiencing spring. So the opposite of spring is autumn.
Spring equinox. On the 21st or 22nd of March. The overhead sun is over the equator. The equator receives the largest amount of solar radiation. At this time, the northern hemisphere is in the spring equinox, while the southern hemisphere is in the autumn equinox. The angle of the sun decreases towards the poles. On this day, the two hemispheres receive a similar amount of solar radiation, and the length of day and night is the same at all places on the Earth. After this day, it is spring in the northern hemisphere, where the day is longer than the night. In the southern hemisphere, it becomes autumn, when the day is shorter than the night. Autumn equinox. On the 22nd or 23rd of September, the overhead sun is over the equator again. The equator receives the largest amount of solar radiation. On this day, the northern hemisphere is in the autumn equinox, while the southern hemisphere is in the spring equinox. The angle of the sun decreases towards the poles. On this day, the two hemispheres receive a similar amount of solar radiation, and the length of day and night is the same at all places on the Earth. After this day, it is autumn in the northern hemisphere, where the day is shorter than the night. In the southern hemisphere, it becomes spring, when the day is longer than the night.
Well, there you have it now, geographers. As you can remember, the Earth actually moves in two different ways. It has two different motions. It actually turns on its axis, which allows us to have day and night. And that is what we call rotation. And this takes approximately 24 hours to complete. But at the same time, while it is turning on its axis or rotating on its axis, it's also moving around the sun. And this takes approximately 365.25 days to complete. This movement is what we also call a revolution. And this, because of the tilting of its axis, which is the imaginary line that passes right through the center of the Earth, allows us to experience 4 seasons throughout the year: spring, autumn, summer, winter. And because of this tilting and revolution of the Earth, during certain times of the year, we get non-stop hours of sunlight and even 24 hours of total darkness on both sides of the equator. So, with all of that said, I hope you enjoyed the presentation and I hope you learned something new. Remember, feel free to continue to go over this video as much as possible and continue to learn more about the Earth's two motions: rotation and revolution. I am your tutor for today, Donovan Rattray, and do hope to continue to work hard at geography and excel at this beautiful subject. Take care, everyone. Have yourselves a great day, and once again, thank you for tuning in to my lecture series.